What is all-up mass and how can we use it in mass imbalance? Let's find out. Hi, I'm Grant and welcome to the second class in the mass imbalance series. Today we're looking at all-up mass, what it is, how we use it, and by the end of this video you should have a firm understanding that will help you to answer a few questions in your exam. So the mass of an aircraft is a combination of various parts summed together, which gives us our total weight or our all-up mass. The weight will change from flight to flight depending on how many passengers we have, how much fuel we take, and the weight of the plane changes throughout the flight as we burn fuel. Even the number of passengers can change during the flight if some jump out with a parachute on their back, for example. All-up mass consists of 4 parts. We have our basic empty mass, our BEM. We have our variable load, just use that a V, our traffic load, and our fuel. Basic empty mass is the mass of the aircraft. Empty as you find it first thing in the morning. It's the aircraft weight or mass, including non-fuel based fluids such as oil and hydraulic fluids in the engines. It includes all safety equipment and also any fuel which is considered unusable, such as fuel that is left in the fuel lines that you wouldn't be able to use in the fuel total. The variable load is the crew part of the all-up mass. It's made up of crew bags, catering, and potable or drinking water. It is what the operators need to run the flight, basically. The traffic load is the passenger part. It contains passengers and their bags, and in the case of a cargo flight, it is the cargo. Traffic load also includes something called non-revenue load, which, as the name implies, is load that does not make revenue. It's not paying for the space. An example of this would be taking a spare part on one flight that you have to hand off to another aircraft or another airport at another base. Or if you have pilots that are repositioning or crew that are repositioning, they would go in traffic load because they are non-revenue load. Fuel is what we take with us for the journey. I will break it down further later because it comes into a few subcategories, but just think of fuel as implied. So a quick example of how we'd use these things is if we get given an all-up mass of 10,000 kgs and we're asked to find the traffic load. We've been given the basic empty mass of 5,500 kgs. We've been given our variable load, which is 500 kgs, and our fuel is 2,000 kgs. It's a simple addition, subtraction calculation. We've got 10,000, which is the total. We've got basic, which is 5,500. We've got variable, which is 500. We've got fuel, that's 2,000. What space is left over for the traffic load? 10,000 minus 5,500 minus 500 minus a further 2,000 traffic load, we still have 2000 kgs left over. Now there's a couple of ways to group together all up mass that are used quite often. So we have our ones that we talked about earlier, our basic empty mass, variable load, traffic load, and fuel. The way that you can group them together are usually dry operating mass, usable load, operating mass, and zero fuel mass. Okay, what do each of those mean? So if we take the top two, the basic empty mass and the variable load, that's what we consider our dry operating mass. If we then add some fuel to it, you can think of it as wet operating mass or just normal operating mass. So dry operating mass plus fuel equals our wet operating mass. The usable load is what is left out here. So traffic and fuel is considered usable load. Don't ask me why it's called that. I suppose you can use them up on the flight. It's called usable load. Next one to talk about is zero fuel mass. As the name implies, the top three, we don't include fuel. So that's considered our zero fuel mass. Is usable load, is our dry operating mass plus traffic. Handy way to remember this sort of arrangement is by using a silly acronym. B, very tall for dunking unbelievably awesomely. I know it's crap, but it does help you remember it. And lay it out this way, because then you'll remember that you just have to draw these parts, you add fuel here, and then the zero fuel mass. Hopefully you can remember that it's just the mass with zero fuel. So a quick example of this in action is we're given a dry operating mass equal to 8,000 kgs. Our traffic load is equal to 3,000 kgs. And fuel is equal to 2,500 pounds. And we're asked to find what the all up mass is. So using that very stupid mnemonic, be very tall for dunking unbelievably awesomely, we can see we've got dry operating mass, which includes these two. We've got traffic load here, we've got fuel here. So we just need to add them together. All sorted. The only gotcha in this question is we've got 2,500 pounds, everything else is kgs. So we'll just convert that first. And we know we've got these two. We know we've got fuel, and we know we've got traffic load. That's it. 2,500 pounds, we want that in kgs. We know kgs are bigger, so there's going to be fewer of them. We'll therefore divide by a conversion of 2.205. And we come up with an answer of 1136.36 kgs. And then it's a simple addition exercise. We know that's our fuel. We know traffic load's 3,000. We know dry operating mass is H1000, which includes basic empty mass and variable load. 8,000 plus 3,000 plus 1136.36 gives us an all-up mass of 12136.36 kilograms. Okay, I said earlier that fuel has some subcategories. Now I'll just take you through them. The first one to talk about is taxi fuel. This is simply the fuel to get out to the runway from the gate. At a bigger airport it's going to be bigger, and at a smaller airport it's going to be smaller. It's the taxi you use whilst taxiing out. Trip fuel is how much fuel you use to get from one point to the next. Contingency fuel. This is used for unforeseen changes, such as if you have to avoid a big thunderstorm and go around it. This is included in your contingency, or if you get given a slightly different routing than expected on your flight plan. This is where the contingency helps you out. Alternate fuel. This is the fuel to get from the missed approach airport at your destination to landing at the alternate airport. So you're flying in down to your destination over here. You can't get in for some reason. Your alternate fuel starts here at your missed approach point, comes all the way around until you land at your alternate. So this portion here is your alternate fuel. Final reserve fuel. This is the absolute minimum fuel that must be on board for landing. If it's not on board at landing, then it is considered an emergency. It's a mayday call, and you should get priority landing, get on the ground straight away if you go into your final reserves. The value of final reserve depends if you are in a jet aircraft or a piston powered aircraft. For jet aircraft, it's equal to 30 minutes worth of fuel, and you're holding above the alternate airport at 1,500 feet, 1,500 feet. The reason for this specification is aircraft burn more fuel lower down they are, and they're working harder. So there is a big difference if you're at 1,500 feet or if you're at 10,000 feet, for example. So it's 30 minutes at 1,500 feet. If you're in a jet, if you are in a piston aircraft, it's still at 1,500 feet, but you need a bit more. You need 45 minutes. You have something called extra fuel, which is the commander's discretionary fuel. So if the captain thinks that it's going to be really busy and you might get delayed going in the middle of summer into Gatwick, for example, can be really busy, captain might think, oh, we'll probably hold for 10-15 minutes, I'll take that amount of fuel with me. So this is commander's discretion. The total of all these together is what you call your block fuel, or your ramp fuel, sometimes referred to. Another thing to talk about when talking about fuel are procedures where you need to take more fuel. These procedures are known as additional procedures, so you have additional fuel. And this is to comply with things such as if you have equipment missing and you're going to burn more fuel, there's a document called the MEL, Minimum Equipment List, and it'll give you the fuel burn, and it'll be a rate that's above normal. So if you have, you're going to burn an extra 20 kilograms of fuel with in your flight, because of this bit of equipment that's missing, this would come under additional fuel. An easy way to remember the whole fuel breakdown is taxi, trip, cafe. So you've got taxi, we talked about that, taxi fuel going out. Trip, the trip fuel. Cafe, contingency, alternate, final reserve, extra, and additional comes after that. Another point to talk about when speaking about fuel is the concept of specific gravity. This is a relation between the volume of a liquid and its mass and its density, essentially. Specific gravity is always in reference to the specific gravity of water. If you know the metric system at all, you know that 1 litre of water equals 1 kilogram of mass. The specific gravity that we use for water in that case is 1. We multiply by 1 to get the weight. The specific gravity comes in here as your conversion factor between the two. Now, fuel weighs less than water, so its specific gravity is not going to be 1, otherwise we're going to be overestimating how much fuel we have. So for example, fuel typically will have a specific gravity of around 0.8 because it is less dense, it's lighter than the same amount of water. So if our specific gravity of fuel is about 0.8, then 1,000 litres of fuel would only weigh 800 kgs. So in a question, if you're given the fuel, pay attention to whether it's in litres or kilograms or volume or mass. Also look out for any specific gravities and use the conversion between the two to make sure you end up with the correct weight / mass of fuel. So to summarize, be very tall for dunking unbelievably awesomely. Taxi trip to the cafe. So I have here a example flight plan of a flight I did to Alicante a while ago, and you can see the fuel breakdown here. I'm just going to show what it looks like in a real world scenario. So we remember taxi trip, cafe, anything additional. So taxi fuel in here we've got 182 kgs. Trip fuel, point A to point B, we've got 6,900 kgs. You can see down the next column, it gives us our time expected for each of these sections. So that's going to be 2 hours 50 and the distance there of 1,163 nautical miles. Taxi trip, cafe, contingency fuel here. Contingency fuel procedures we'll get to in the ops classes. But for now, just know that it's 300 kgs with 7 minutes. That's our avoidance fuel, any unforeseen circumstances fuel. Alternate fuel, that's for us to get from our missed approach point at the destination to our alternate, which today we have as LEMI, which is Murcia. The distance away is 111 nautical miles here. 111 comes across. Time to do that is 26 minutes. 26 minutes comes across, and the fuel we need is 1119. Our final reserve fuel, we know it has to be 30 minutes if we're in a jet, which we are, so we can see the time there of 30 minutes, which in this aircraft is 1,094 kgs. Our extra fuel down the bottom has not been added in on this flight plan because this is just a copy. But on the actual day, the commander would come down here, write in some numbers, and we'd recalculate our block fuel from that. And then we'd phone up the guy who works at the fuel pump, and he would fill our aircraft up to that new value that we've calculated. So additional fuel. There's a bit of additional fuel in this flight plan. The first bit is this LLV, which stands for low level. This is because we were going at quite a busy time, and our desired flight level, our desired altitude that we would want to fly, might not have been available. So the flight planning department at my airline thought to give us an extra 75 kilograms of fuel in case we don't get up to our desired level. Because if we're not at our desired level, our fuel burn will be different. And if it's a lower level, it's going to be worse. So we're going to need more fuel. ETOPS is something called Extended Twin Engine Operations. Extended Twin Ops. And this is for use on very long routes where you go quite far away from airports and you only have 2 engines. It's covered more in the ops lesson, but it basically has to do with having to maintain certain standards to be able to fly far away from airports. And you also need additional fuel requirements as stated here. It's something more concerned with, crossing the Atlantic or crossing large oceans. MEL/CDL, covered that briefly before. That's if we have any items on the minimum equipment list and any associated fuel penalties to do with that. So today our aircraft was fully serviceable, so there was nothing broken on it that was causing us to burn more fuel. And you see all of that added together, our taxi, trip to the cafe, and any additional, gave us our total there.